Hey everyone, and welcome to Enhance Smart Skills. Today, we're going to peek under the hood of AI and find the tiny smart switch that gives it all its brain power. So let me ask you something. Have you ever wondered why your phone can unlock with your face, but a super powerful calculator can't? It's a great question, right? I mean, a calculator can do crazy complex math, but it gets stumped by something that feels so simple to us. Well, the secret lies in this one special component that lets AI learn from all the messy, complex patterns of the real world, something a calculator with its super rigid, straight-line thinking just can't do. And stick with me, because by the end of this, you're going to know exactly what this smart switch is. We'll cover the 3 most important types, and I'll give you a super simple guide so you know which one to use for pretty much any project. All right, let's dive in. So first things first, why does AI even need a switch? Well, imagine trying to draw a circle using only straight rulers. It's impossible, right? Without this little switch, an AI can only think in perfect straight lines. But the real world, faces, voices, the way we talk, it's all curves and squiggles and complex patterns. Straight lines just don't cut it. And this really shows the difference. On one side, without these switches, AI is basically just a fancy calculator. It's stuck dealing with simple linear problems. But you flip that switch, and suddenly it becomes this learning brain. It can start to see all the nonlinear, messy, and kind of beautiful patterns of our world. This switch is what really unlocks its power. Okay, so what is this magic switch? Well, it's called an activation function, and you can think of it as the tiny little decision maker, kind of like the brain, inside every single artificial neuron. So what does it actually do? Well, just picture an activation function as a tiny gatekeeper standing at the door of a neuron. Its one and only job is to look at the information coming in and decide, hey, is this important enough to pass on to the next neuron? It's really just a simple go or no-go decision for every bit of data. This quote really just nails it. If the input is strong enough, pass it forward. If not, stay quiet. The activation function is always asking that one simple question. Is this signal strong enough to matter? If it's a yes, the message goes on. If it's a no, it just stays quiet. And that's so important because it stops useless noise from junking up the whole network. So here's how that decision happens, in 4 easy steps. First, the neuron gets a bunch of inputs from the layer before it. Second, it adds them all up to figure out the total signal strength. Third, and this is the crucial part, it applies that activation switch to decide if that signal is worth passing on. And finally, if it gets the green light, it sends its output forward. That third step, the activation, is where all the real magic, all the intelligence happens. All right, let's get practical. Think of all the different activation functions out there like tools in a toolbox. The good news is you don't need 100 of them to get started. In fact, you can solve most of the problems you'll run into with just 3 main tools. Okay, tool number 1. This is the big one. It's called ReLU, which is short for Rectified Linear Unit. Honestly, this is the workhorse of modern AI. You are going to see this thing everywhere. So ReLU's job is super simple. It's basically an on-off switch that only likes positive numbers. If an input is positive, ReLU just says, yep, you're good, and lets it pass right through, no changes. But if the input is 0 or a negative number, it says nope, and just turns it into 0. And that's literally all it does. So when you actually use this thing, the answer is almost always. For any of the hidden layers in your neural network, that's all the middle layers between the very start and the very end, ReLU should be your go-to, your default choice. Why? Because it's incredibly fast for computers to process, and it helps the network learn way more efficiently without getting stuck. Okay, let's grab our second tool from the toolbox. This one is called the sigmoid function, and it is perfect for when you need a clear yes or no kind of answer. I like to think of sigmoid as a probability meter. What it does is it takes any number you give it, doesn't matter if it's huge or tiny, positive or negative, and it squishes it down into a value somewhere between 0 and 1. And this is super useful because now we can treat that output like a probability. So an output of, say, 0.9 could mean there's a 90% chance that something is true. Now, you're going to use sigmoid in one very specific place, the final layer of your network. And you'll use it when you need a simple yes or no answer. This is what we call binary classification. Is this email spam or not spam? Is this a fraudulent transaction or is it legit? Sigmoid gives you that final probability so you can make the call. And that brings us to our third and final essential tool. This one's called Softmax. You'll pull this one out when a simple yes or no just isn't enough to get the job done.
Softmax is the choice maker. What it does is it looks at a bunch of different scores coming from the final neurons, and then it magically turns them into a list of probabilities that all add up perfectly to 100%. This is what allows the model to say something like, I'm about 70% sure this is a cat, 25% sure it's a dog, and maybe 5% sure it's a horse.
So just like Sigmoid, you only use Softmax in the final output layer, but you use it whenever your model has to choose one option from more than 2 categories. We call this multi-class classification. For example, is this picture a cat, a dog, a horse, or maybe a bird? Softmax gives you the probabilities for each one, so you can just pick the highest one and be confident in your answer.
Okay, so we've got our 3 main tools, right? ReLU, Sigmoid, and Softmax. Now let's put it all together. I'm going to give you a super simple guide so you'll never have to guess about which one to pick for your project.
Because that's the question that really matters, isn't it? When you're building something, how do you actually choose the right one? Well, the good news is it's a lot simpler than you might think.
And boom, here it is, your official activation function cheat sheet. It really just boils down to this. For almost any AI task, when you're setting up those middle hidden layers, your default, your number 1 choice is ReLU. Easy. Now, if your final output needs to be a simple yes or no decision, you use Sigmoid in that last output layer. And finally, if your model needs to pick one thing from a list of 3 or more options, you use Softmax in the output layer. And that's really it. It's that straightforward.
All right, before we wrap up, let's just quickly go over the 3 simple rules you need to remember. This will help make sure all this new knowledge really sticks.
Let's lock this in. Rule number 1. For all those hidden layers in your network, just start with ReLU. It's fast, it's reliable, it's the default for a reason. Rule number 2. If your model needs to give a final yes or no answer, use Sigmoid in that final layer. And rule number 3, if your model has to choose one category from many, like cat, dog, or horse, use Softmax in the final layer. If you can master these 3 rules, you are well on your way. And just by understanding these 3 simple tools, you now have a fundamental knowledge to make your own AI models so much smarter, so much more powerful. You've really learned how AI stops being a simple calculator and starts becoming a true learning machine. If you found this video helpful, please like the video and subscribe to Enhance Smart Skills for more videos like this.